Hello, we're here on Offsite Dirt. Offsite Dirt is a construction news platform on all things offsite. Offsite construction is typically built in a manufacturing plant, whether it be panels, containers, volumetric, and then we have spanned into our new series called The Dirt. And The Dirt expands into passive house design, low carbon footprint, high performance. And of course, we are here joined by Mark Wille, and Mark Wille is going to introduce our two guests today.
Thank you so much, Audrey. Today we're going to have a wonderful discussion. We're joined by two of our friends, Ilka Cassidy, Steve Hessler of Holzraum System. And, Steve's background is with heavy timber, structural design, and project management. So you're going to hear echoes of that throughout what he shares with us. And he's also a certified passive house consultant. And the details that you're going to be hearing from Ilka are reminiscent of her experience throughout the industry. She is also a certified passive house consultant, and she studied engineering and architecture in Germany as well. So let's get the conversation started, Audrey.
I love jumping in and love being with two major experts in the field, and it's going to be exciting to hear about their systems and technologies of what they're going to be bringing to the marketplace. We're going to jump in with how does the model of SIM take the design intent into a collective of perspectives and become a communication tool?
Yeah, good question. And first, thanks for having us today. We're really excited to share what we've been coming up with over the last years. Steve, how many years has it been?
Like, it's probably 6 or 7 years, I guess, that we've been talking about it anyway.
Yeah, we actually started out with just kind of building together as an architect and builder, and just kind of saw what, where they were kind of
some opportunities and missing processes, maybe. Yeah,
between architect and builder and manufacturer, actually.
Yeah.
So and that's kind of when we started thinking about this the SIM model, and it actually stands for it describes a parts-based model, and it stands for single integrated manufacturing model. And it basically takes the design intent from the architect and turns it into a parts-based model that then generates outputs needed for offsite manufacturing. So that's kind of the main thing. And then, so the key actually is that once you make that decision to go with offsite manufacturing, you actually need a parts-based model. So I think that's something that, a lot of people are like, what is it and why do you need it? But if you look at basically a shop drawing, you really see every single piece that goes into manufacturing something. So, and that's basically what we do in for the whole building. It's like a shop drawing for the entire building, and that is pretty different from what an architect does or architecture documentation, which really looks at design intent and the documentation, looking at schedules and floor plans and all of that. And for us, it's quite different, because we, in our model, once we turn it into a parts-based model, we can really show basically every single component, kind of down to every stud, to every fastener, every membrane, and even tape. So that's quite different. It's a totally different level of detail. So and because we have that, and it's not going to change, because otherwise it wouldn't be, it wouldn't go together on site. We know that everything is going to stay in that location. So we thought it's kind of a missed opportunity to not use this model more. So we started looking at all the other pieces that go into a building and started to visualize those as well and take them into that one integrated model. So and that's basically other perspectives like steel and in general structural load path and MEP and concrete and air sealing, and all these things all go together in this SIM model. And because all of a sudden now everyone can see it, it becomes a communication tool. So because everyone, looks at the same thing, because a lot of times when you just have like a 2D representation or you just use words to describe an issue, everyone hears something different, correct? So by visualizing it and really being able to, through Zoom meetings or, through file transfer, all of that, we all look at the same thing. And that's basically, why we call it a communication tool. Having this this digital twin basically allows us to have a conversation before anything gets built. I think.
So I was going to just add then, if we dive like a little deeper into the sim for a minute, the sim allows us to create like sort of a foundation for what we refer to as a project's design to manufacturing environment. So inside this sort of DME, all exchange content and collaborative discussions can be funneled through the lens of making and manufacturing instead of just regular design intent. So a critical piece to creating a parts-based model that will serve this sort of design to manufacturing environment is a model that's going to start from schematic pricing, and it's going to evolve all the way into fidelity production ready manufacturing model. Is the key to making a model like that is software used and design approach implemented. Since manufacturing requires really precise geometry and the ability to attach and process and track data, we use a production design software called CADWork. Having the kind of the power of a production design software from the very beginning, it kind of allows us to sort of look at the building differently, and it's really changed the way we look at what the different design phases are for us. So for us, the different design phases of a project would be schematic and design development, documentation, and then production support. And production support can be support for the factory, can be machine files, it can be shop drawings, but it doesn't have to just be for the factory, because the model, as Ilka explained, has all these different perspectives in it. We can support all of the makers, and I'm going to talk more about that later. About this model is really through the lens of makers, and makers are factories. They are all these different perspectives. So kind of by working through this production makers lens, we're bringing all the project, its teams, their work, and all the goals of Passive House into kind of a custom tailored design to manufacturing environment. It's sort of like we're sort of simulating what happens in a factory, but we're doing it with everyone that's going to make something for the building, and they all have a voice and they're all in the room. So that's kind of it. And then I just want to say one more thing that Ilka touched on about data. It sounds a little bizarre to talk about data when you're talking about a building, but the reality is that in regular conventional building, we all deal with data every day, all day. So, material specifications, manufacturers' product models, vendors, delivery and installation sequence, structural design criteria, thermal and vapor performance, responsibility assignment, costs, building phase. Like the list of data that's important that we all need to complete a project is gigantic. The problem is that it comes to us from dozens of sources in dozens of formats, and that makes it really hard to get your hands on it quickly. We attach that data, all of that data, to our sim model objects, and Catch is a tool we've developed to access it and have dialogues about it extremely quickly. Through the sim and Catch, everyone on the project can access the 3D model and all this data without any software license or design skill set.
This is great, and I love how we started out, Steve, how you both fed off of each other. It shows the integration of your team. And for the folks that didn't get that, I want to reemphasize again, the sim is the single, right, integrated manufacturing model. So as Steve mentioned, thousands of questions and things are going on, and dozens of different programs put it together. This is the single. That is the perfect word to start that. And then the segue is coming up, Steve and Ilka, it's coming up. you said it right there. You said catch. And I can't wait for you to explain more. Can you please explain what catch is and how it's useful?
Well, catch is something else that, with the name, Steve is really good at naming things. So he thought catch would be a really great name for the next thing that we came up with. Because so what we ran into with after, we're creating the sim model and we attach all this data and we want to communicate. So all of a sudden we actually have a lot of power on the project team, right? Because everyone is looking towards the sim model, needs to be updated, and more perspectives need to be integrated and more data is attached. And then we started being the ones herding the cats, basically, right? So, and we kind of needed a tool to do that. Email wasn't sufficient anymore, and data transfer, or even just kind of document transfer, because we are working with different teams all the time. Like we are just part of one bigger team, or we're basically helping to put the team together. But it's always someone different from a different perspective, with different backgrounds, with different software and knowledge, computer knowledge, and somebody uses Google and someone uses Dropbox, and so we definitely had quite a bit of back and forth and trials and mistrials of really communicating all these different perspectives to everyone. So we luckily have a third partner, which is David. He does exist, and he is Steve's brother. And he happens to be a software developer in his former career. And of course, we took advantage of that. And he's really good at what he's doing. So we basically said we need something. So, and we always knew that just by kind of starting this whole process, we always knew that, kind of streamlining and getting faster at things would be key, and that software would play a role in this process. We
always remember we would talk about automating design. We were like, I don't know what that means, but we need to automate design somehow, or parts of it, and that's what we told David, right?
Yeah, and I don't know if we ever really got to automating design per se, or how to use the
little pieces of it. But you're right, streamlining it.
Yeah, so I think we realized just kind of streamlining the communication between all team members was actually really, really important, because as we said, we're creating this visual, digital twin, or this visual database, but it doesn't really help if we can't get the data out of it, or if we can't really communicate and send files along. So David started developing Catch, and as Steve said, it's a cloud-based software or tool, so everyone can use it. You don't need any special software. You don't need any any background knowledge in any kind of 3D software. So it's really geared towards everyone being able to use it, and everyone being able to just kind of start at the same, or being on the same page, basically. So, and Catch is where we basically collect all the information and all the most of the communication in one place. So, and in a way, we developed it to be a counterpart to the sim, because, Steve explained that we connect or attach all this data to those parts, but, if it just stays there, it doesn't really help anyone. Correct. So we needed a way to, besides kind of communication, we also needed a way for everyone having to have access to the 3D model and through to all that information that is attached to that. So basically, the sim model gets built in CAD work, and Steve is the CAD work master. He's been doing it for how many years? 20? You always said 25 years. Yeah. So he's really, really good at it. And so the sim model, gets developed with all the design inputs and perspectives, and we import models that we get from the engineer, for example, and so it's all there. But now we actually, through Catch, have the ability to basically export the sim into an IFC file format. And then in Catch, we have an IFC viewer. So everyone can just click, it's just online, it's cloud-based again, and has access to this 3D geometry of that sim model without needing CAD work, without needing any schooling. So it's pretty easy to just kind of look at it, rotate it, turning parts on and off, and all of a sudden, everyone again has access to it independently. They don't need us anymore, so they can just kind of log into it and look at everything, mark it up. That was a big key to that. Now we connected the geometry to an issue tracker. So basically, you can mark things up, you can save views and log it into issues, and then send it out through an issue email to whoever you want to. So this is kind of how we use that geometry for, again, communication with everyone. And then the data can actually also be exported into a CSV format. And, a lot of builders, a lot of the factories use that file format to basically make lists for takeoff data and,
ordering data and anything they need.
Yeah, ordering material and all of that. So this is something that can be useful for the builder, but for us, it was really important to make that very usable for the manufacturer, because for them, it really goes down into how many fasteners do we have to order, and how many feet of tape and all of that. So they all have access to those, the data, to the lists, and they can basically, they can just integrate everything into their workflow. So besides that, we integrated some other things like easy document uploading, since not everyone uses Google or whatever. So that was a really, really important thing for us too, that everyone just, we can upload documents and everyone has very, very easy access to that. And in general, issue tracking takes place a lot instead of writing emails, and they're all logged. It's really easy to go back and find those issues. So and there are a bunch of other functions that we have, but basically it's all around getting everyone on the same page and communicating the data that is attached to the sim.
Should we give you a demo of the sim and Catch?
I think it's a great catch, and let's go for it.
All right.
The sim modeling approach works really well with all types of building shapes, designs, and construction approaches. We work primarily on single-family residential projects. However, we've provided sim modeling on small commercial and multifamily projects as well. Whether we're working through complex passive house roof systems, modern passive house homes with challenging cantilevers and load pass strategies, or a 10,000 square foot historical precedent-inspired passive house, sim allows us to create our parts and fully coordinate them with everything else. This is a site-built passive house in Baltimore, and a panelized passive house near Philadelphia. This is a mass timber and glue lamp structure with integrated steel frames in Ontario. This one goes into production with Element 5 next month. On this project, we used sim to design this timber frame and passive house enclosure for our client in New Jersey. This sim helped us design the high-performance enclosure and mass timber and glue lamp system, and then import and coordinate structural steel, other wood load path parts, MEP, windows and doors, and then make sure all of the parts get along with each other before any materials are ordered. Modeling production fidelity parts and assemblies from the beginning allows us to analyze real build scenarios early and throughout the design process, and then share and discuss them in real time with every member of the team. The 3D Sim allows us to communicate and collaborate on every complex condition without needing to draft complex 2D details for each unique situation. The more accurate parts you integrate, the more you see and know, and the more risk you eliminate. The bottom line is it allows way more visibility and much less drafting. Detail and nuance from so many parts make our models pretty complicated. To speed up navigation, we've developed ways to split up and organize the sim with subroutines and data navigation. This isolated portion of the sim we're looking at is called a building core. The smaller versions you saw we call nuggets. Core nuggets contain clones of the actual parts with all their data attached. So we can activate parts that share any data value and isolate them for analysis and modification. We can visualize parts from any combination of building perspectives. This allows for very detailed comparison with very little effort. So during the meeting, we can talk about all the relationships between the parts. We can assign unlimited data to every part. Besides speeding up navigation, this data serves lots of other functions. Shop drawings and machine files allow the factories to produce the modeled components efficiently and with super tight tolerances. Here's what that looks like at New Energy Works, our factory partner in New York. We provide CNC files for speed cutting all of the framing parts, as well as files that instruct all CNC routing and nailing for wall and roof panels. Despite the use of machines, high quality panels require a very highly skilled crew. So we only work with a handful of vetted factories throughout the US and Canada. Let's take a look at Catch. On the homepage, you can access documents, issues, and 3D models for the project. Issues can be organized along perspectives and progress status, and watchers are assigned for notification. Anyone can comment on an issue, and image and hot links can be added to any comment. Let's go back to the home page and explore another project to see some possible workflows. From this new project, I can browse and select from saved viewpoints from multiple viewer models. Inside the Catch IFC viewer, I have real-time access to all of the sim's data and geometry from date of model export. Versioning can be viewed on the project page. I can filter along any data value to activate and isolate parts, and then build on the selection set with additional filters. In this case, I've activated exterior walls, and now I'm going to add foundation. Data grid can be used to drive visualization or be used to browse data independent of the model view. This time, let's filter all SPF framing in the building. Independent of what's in the viewer frame, I can filter the grid to SPF and export a CSV material list. There's no limit to the ways you can configure your list outputs, and everyone on the team can export lists at any time. No software or design skill set required. Now let's activate along load path scope and CLT material and take a closer look at a particular connection we're curious about. I'll turn off the other parts and zoom in to inspect. I'm curious if this thermal break connection was completed and wish to communicate my question to the team. I'll recall an existing issue on the topic and will create a new comment with a link to this precise filter and position in the viewer model. I'll confirm that my viewpoint posted. Yep, now everyone can see it in the issue tracker as well. I see my viewpoint comment and the watcher is just notified. Back on the project homepage, I can expand the viewpoint browser and select a building core to check out. These cloned parts have all the same data as their parent from the master sim.
So that is very interesting. I look at this whole conversation, builder studies technology and passive house and principles, to then building a software platform that now integrates all of these solutions together. It's amazing, all of the different pieces and how they all connect together in this single principle. It's really phenomenal. How can manufacturing part of offsite industry, high performance, passive house designers, architects, site contractors, builders, how can they work with these Holzraum system?
Well, for us, every step of the way, we're actually looking through the lens of all the project's designers and also the makers, like I mentioned. And, by makers, I'm really referring to the project's builder, concrete contractor, framer, finished carpenter, HVAC installer, equipment manufacturers, high performance tape, membrane detailers, electrician, roofer, drywall, stonemason, timber framer, excavator, plumber, panel, heavy timber manufacturer, and like way more than that. I mean, there's a lot of makers in a building, and we really are looking through that. Any team member who will be creating physical parts of the building, whether they do it on site, in their garage, in their shop, or in a 5-axis robotic manufacturing facility, they are all makers. And through this lens, we build an inclusive model that can be used to deeply coordinate and vet the relationships between the different makers' work before construction starts. A sim allows us to see and analyze all the part relationships before the team is on site and make the best decisions before any material or assemblies have been ordered. It forces the collaborative design team to consider all the makers, their parts, and the factory schedule. And the factory schedule is a huge motivator.
Yeah, so I think for me to basically sum it up, using the sim and catch and working with Holzraum system, I think the main benefits are predictability and risk mitigation, because what happens is that we actually perform construction administration before anything is built. And that's actually important for the architects that are working with us. And I think I learned that when I went through our first project as the architect with a pre-manufactured building, that if you write your contract as an architect, you basically put your hours for construction administration way before. It's part of design development, basically, or construction drawings, or it's definitely happens way earlier. But then on the other hand, once that's all figured out, not much construction administration actually is going to happen on site. And we actually got that feedback from a structural engineer as well that we worked with on a recent project, where he came back and said we've never not been called once the building started. So that's definitely something that is different, and is good in terms of predictability of change orders, or not that many change orders that might occur otherwise. Sorry. And then the other thing too is I feel like it gives everyone a lot more control over this design process and the construction process. And again, from the perspective of the architect, all of a sudden you can make decisions and it's gonna be built like that on site, even if you're not there. And I think the same is, counts for the builder. A lot of times thinks that they're not in the conversation early enough, that they basically just kind of, you throw them some plans and they have to price it and then figure out how to build it. So we like to integrate everyone early on and really get everyone's opinion on how to build this, with, of course, the outlook to the manufacturing piece. So we always bring that to the table, that everything is looked at through the lens of how do you actually manufacture that, and how do you actually put this together? What is the staging? What is the sequencing? So again, a lot of predictability there. And then the other thing that I feel like is really, really important is that by building this team and bringing everyone onto the same page and being able to have these conversations, it really unsilos workflows. So I think that's really, really important, and that the industry has to move more and more towards, not being in bubbles anymore, talking to each other, figuring things out together before there's a big dollar sign attached to it. And yeah, I think that's definitely a way to do that.
This is so fabulous. I always enjoy sitting down with you guys. The questions today are fantastic, right? I want to stress it every single time, SIM, right? The single integrated manufacturing model. SIM. And then we dove into the catch, and there are some real nuggets in there about how catch helps the workflow. And it truly is a communication tool from all those voices, and the ability to catch on to those things. These are the many benefits of working with Holzraum System. That's what I heard today, Audree. What more did you hear?
The thing that I really like that Ilka really emphasized and Steve emphasized is the team and building the team and making sure that we have these vehicles of communication. As we all know, with offsite solutions, we have to do everything in the pre-construction. We really have to get involved early. I like that they have created a system that catches all these different pieces and being able to communicate it and really defining, having this predictability and also this risk mitigation is huge in any project, and being able to pick up some software and to be able to watch the flow and understand how it all came together, and then easily being able to communicate with each other is only going to be a benefit. And I can see this huge impact that it can make in the offsite manufacturing industry, especially on the development of that project. So very nice job, Ilka and Steve. Thank you very much for explaining your system. And if you can let us know, what is your website in case people want to check it out?
It is www.holzraum.com.
Perfect. Yeah, I think that's huge. And Ilka, thank you for your time. Is there anything else that you'd like to say before we close?
Well, thanks for your time as well. Always happy to show up and talk about what we do and try to develop. It's it's something new every year that we figure out and that we focus on, and it always changes, just like everything changes. So it's been a lot of fun.
Thank you. Thank you for being here, everyone. Thank you, Mark, for being here. So it's always good to get more information and to filter what else is happening in building science and how we can collectively get better and communicate and build better structures. I'm Audree Grubesic with Mark Wille on behalf of Offsite Construction News. This is The Dirt, and we thank you for being here.
Thanks.
Thank you.